Okay, Assalamualaikum warahmatullahi wabarakatuh. Today I'm going to finish off the pointers topic that I left. Earlier we have learned about pointers, the introduction of two pointers. So today we are going to learn pointers in relation to arrays and also functions. Okay, so the relationship between arrays and pointers, we have learned before that how we use arrays as arguments to a function. So similarly, this is similar to pointers, how pointers work. Okay, so for example, when we pass arrays through function call, we have something like this: show value, numbers, and size. But it means that it will show value. Numbers is the array. Okay, so in the array, and the size is the size. So of course the size will go to the integer variable, the single variable, and the numbers here is not the whole array, but it's the base address of the array. Base address means the first address of the address of the first element of the array. So it will uh, pass the first address of the element of the first sorry the address of the first element of the array to the function, to this parameter here. From there on, they will work from this base address, and using count, they increment to access the next element and the next element. Okay, as long as it's within the size, right? So if you could see here, you have an array with 3 elements. So if you print out vowels only, it will give you the address of vowels, and if you print out vowel 0, it will display 4. So I have this here, but let's go through the slide first. And then if you use pointer to the array, so that one is just for the array, but you can see that how by just put C out vowels, it actually display the address, just like pointer. You will print out the address of the variable is pointing to. Okay, when you use vowels 0, only it will display the value of the array inside, right? Okay, so this is the relationship between arrays and pointer. So that's why when we are passing arrays, we don't need to use pointer. It's not necessarily, but we can still use pointer when in certain situation. Okay, all right. So in this in here, array name can also be used as a pointer constant. So if you use vowels and you put an asterisk here, it will display 4 because it will return you the first element, the value or in the first address, the element. So you can also assign a pointer to the array by initializing the pointer like this: int asterisk vowel pointer equal to vowels. Okay, when you see out vowel pointer 1, it will display the element in the location 1. Alright. Okay, you can also have pointer in expression. Alright, even you can have you can write pointer something like this: val ptr plus 1 simply mean, if you can see, there's a conversion. Where is the conversion? Okay, right. So val pointer plus 1 simply means the address in val pointer plus one size of integer plus under 4 bytes. So which means that wherever the val pointer is pointing now, it will add on one integer of size, so 4 bytes more. So you basically will move to the next, will be pointing to the next element of the current pointer. Okay, this is just to print this for display, but the pointer did not change. It will still hold the first the address, the val pointer, the initial val pointer. Okay, so we'll see that in later. Alright, this is how you access arrays. Okay, you can access array using its name and its square bracket. Vals2, it was always and when you use pointer to array, you can also do the same. Okay, the same things for when you use array as a constant. The name of array as constant point and make it a pointer, constant pointer, so it still give you the same meaning as the above. The same thing for pointer, right? So all these four is accessing the similar uh, elements and location, array location and memory address. So the conversion is vals I is equal to vals plus I. Okay, right. Okay, arithmetic. Right, so the different bit here. Okay, if you have a val pointer plus plus, you are actually incrementing the pointer. So if you are moving the pointing, so your pointing will move. If it's pointing from element 0, it will point to element 1 and so on. And if it's minus, it will reduce. Okay, and but if you have something like this, val pointer plus 2, you are actually displaying the value of the pointer, pointer pointing to the next two element without moving the value of changing the value of val pointer. We'll see this later in the example bit. And this one is when you do this val pointer plus equal to 2, you are moving the pointing. Okay, and val pointer minus val, you are showing the difference, how many integer value that the difference that reside between val and also uh, val pointer. Val is the first address of the array, and val pointer is wherever it's pointing at the moment. So let's say the first address is always 0, and val maybe it has moved to location 4 for 4 minus minus, so 4 0 1 2 3, so 4 integer elements. Okay, let's try this out. So I have made the program ready. Okay, I'm going to open it one by one. Okay, so now I have an array with 7 elements. These are my list. Okay, I don't have to describe the size because my list actually the array will be created based on the size of my list. And then I have the array pointer that pointing to this array. So I'm going to print out array and array 0 to show you from the beginning. Okay, so you can see that array, by printing out array only, is giving me the address of the first element of the array, and the value of array 0, we are accessing the element, and is 2. The value is 2. So now I'm going to see out array pointer. Okay, and what happened to array pointer plus plus. Okay, right. So now I have array pointer. And the value of array. Remember the asterisk down here, it displays the value that the pointer is the content of the address the pointer is pointing to. So in this case, the address that is pointing to is this address, and the value inside is 2. Basically, it's the first address of array, the first element of the array, and the value is the same too. And then when I do array plus plus here, array ptr plus plus, array pointer plus plus, I'm moving 4 bytes. Okay, I'm moving 4 bytes, which means I'm moving to the next integer value, which is 4. Our array is 2, 4, 6, 8, 10, 12, 14. Okay, so this become 4. The value is 4. Okay, let's open the next one. Okay, when I do this, oops, sorry. Okay, what happened to this? Okay, remember this will be showing the content, yeah, without changing the pointer value, right? In this case, when I do asterisk is the value, so value of array pointer plus 2, which means that wherever it's pointing now, plus 2 integer. So now I'm at 4. Okay, I'm at 4 with address 24, so I will be pointing 2 more integers. Okay, I'll be pointing to 2 more integers, which is 4, 6, 8. So the content of the value of it will be output, but the value of the pointer after that still remains the address of the second element, because nothing changed to the pointer. Because we only do this temporarily, where we allow the pointer to point to two integer above, in forward, without changing the address of the current pointing. Okay, is as opposed to this one. Okay, so let's change this to 2. Okay, as opposed to this one, because you did some arithmetic to the pointer itself. Okay, compile this and 1. Okay, as opposed to this one, you can see here, just now we are here. So now when I do array pointer plus equal to 2, I'm actually adding, making the pointer really move. Here the pointer pointing, but it doesn't really move. So this one, it really move. So when I print out the address is different than before. This is the address of 4. This is the address of 8. The value is still 8. Okay, so these are the two different things. This one only display the value without changing the address of the pointing. Okay, but this one did change. Okay, the next one is finding the difference between val and the pointer. Okay, if I compile and I run, it will give you 3 here, because from 8 to 2 we have 2, 4, 6, then we got 8. So there are 3 integers. Okay, from 8. So if you want to change, you want to try out, let's say put this 4, compile, and you can see that we are at 12, and there are 5 integer from 0 to 12. 2, 4, 6, 8, 10. Okay, 5 integer before. Right. Okay, you can try out program. Okay, you can try out program 9.7 and 9.5. Okay, I'm going to continue with not yet. Let us do program 9.9.